So we're going to be working on exponents, roots, in the order of operations. Now, how many of you have heard of the term PEMDAS or PEMDAS? P-E-M-D-A-S. What does that mean? Do you remember? Parentheses, exponents. What's M and D? Multiplication, division, and addition and subtraction. Now, why is it important to have an order of operations, some rules about how to do the order? Why would that be important? Because what, Rochelle? Yeah, you'll get a lot of different answers because people would be doing it a lot of different ways. So you want to have one particular way that things need to be done so the answers are uniform. And there's a hierarchy in math when we're doing the order of operations. You have a particular order that you have to do things in. Now, one thing that students always forget is the exponents and the roots. So I do want to take a few minutes to talk about exponents and roots before we actually do the order of operations. Now, I have a term here. This is a term because there's a base and then there's a power here, or an exponent here. The entire thing is called a power. But the 3 is called the base, and the 4 is called the exponent. The exponent is a little number high to the right of a regular or base number. Here's your base, here's your exponent. And it has a particular meaning. By definition, an exponent tells you how many times a number will be multiplied by itself. Now, this expression does not mean 3 times 4. Your brain is going to want to say, oh, 3 times 4, that's 12. Stop your brain, because this is not what this means. This means to take 3, write it down 4 times, and multiply it. So it's 3 times 3 times 3 times 3. Now, who can tell me what that is equal to? Not 12. What's 3 times 3? 9. And 3 times 3? 9. So 9 times 9 is how much? 81. This is 81, not 12. So you have to stop your brain from automatically trying to figure it out by saying 3 times 12. It's going to do that. My brain does it too. But you have to force it to do the actual definition. The actual definition here is to take 3 times itself, times itself, times itself, which is 81, not 12. Also, when you are reading exponents, there's a particular way to read them. Just like we were talking about how to read numbers, we have to also read our expressions when we have them and our terms. So this is read 3 to the 4th power. So everybody say that, 3 to the 4th power. Okay? Now, when I have a 2 for the exponent, I can say it 2 different ways. I can say 3 to the 2nd power, or I can say 3 squared. Either way is okay. So you can say 3 to the 2nd power or 3 squared. When you have an exponent that's a 3, you can also have that 2 different ways of saying it. You can say 3 to the 3rd power or 3 cubed. 3 cubed means that number times itself, times itself, times itself, okay? So there's 2 ways to say 3 to the 3rd power. So you guys help me read these. How would I read this one? 3 squared, or I could say 3 to the 2nd power. What about this one? 2 to the 3rd power, or 2 what?
2 cubed.
cubed. And what about this one? 6 to the 5th power. And this one? 7 to the 4th power. Okay. Now, in this particular expression, I have 2 times 2 times 2 is equal to what expression? What power? 2 to the 3rd power, because there's 3 of them, right? And then what about this one? This should be 3 to the what power? 2nd power. Good. And 5 to the what power? And what's my base here? 8. What's my exponent? 4. Okay. What's my base? And my exponent? What's my base? And my exponent? Now, I want you to remember that anything to the 0 power is 6. Not 6, I'm sorry. Anything to the 0 power, I got 6 in my brain here, is 1. Now look, let me show you why this is true. When I have anything to the 0 power, this is what the 0 power means. In this case, we have 6. This means 6 over 6. Well, what's 6 divided by 6? 1. Now this is true. This rule of to the 0 power, anything to the 0 power is 1. What's 100 to the 0 power? 1. Because that's 100 over 100, okay? The only thing that is not true is if you have 0 over 0. Why somebody would want to do 0 to the 0 power doesn't make sense to me anyway, because it's 0 anyway. So the only time this is not true is when you have 0 to the 0 power. So that rule is true as long as your base is not 0. Okay? Any base to the 0 power is 1 with the exception of a base of 0. So write that exception down. Because 0 over 0 is just going to be 0. It's not going to be 1. And it's the only thing that makes this not true. So anything to the 0 power. So what's 4 to the 0 power? 1. 19 to the 0 power?
1.
Okay. Even if I have variables, it's going to be 1. Now sometimes when you guys have these powers, you have your exponents, I'm going to want you to evaluate them. Just like we did with 3 to the 4th power. And I used a shortcut. What I did was, because I know that multiplication is both associative and commutative, I just did 3 times 3 is 9, 3 times 3 is 9, and then 9 times 9 is 81. You don't have to do it that way. You can just go 3 times 3, which is how much? And then what's 9 times 3? And then what's 27 times 3? 81. You could just do it in a row. Okay? It doesn't matter. You're still going to get 81 just because of the properties of multiplication. So when I ask you to evaluate or put something in standard form, this is what I'm asking for. I'm asking for you to actually calculate what that power would be. Any questions about that? Because you might be asked to do that today. Okay. All right, so what would 4 to the 2nd power be in standard form, or evaluated? 4 times 4, which is 16. So when I ask for the standard form, or I ask for you to evaluate it, you're going to actually solve the power. What would 2 to the 3rd power be? It is not 6. 8, because we take 2 times 2 is 4. Times 2 more is 8. 3 to the 2nd power, 9. 5 to the 3rd power, 125. Now the opposite of a power or an exponent is a root. You can have square roots, you can have cube roots, you can have fourth roots, you can have fifth roots, up to infinity roots, okay? But most of us will only do square roots or cube roots or fourth roots. So you have to work it backwards. Basically, if you're given the square root of 4, you know that's 2, because there are 4 squares here. But to get these 4 squares, I had to take 2 times 2. So the square root of 4 is 2. Now, that 2 can be positive or negative, but we're not doing positive or negative numbers right now. We will in a couple of weeks. So I just want you to worry about the positive root. So what would the root for this be? How many are there? 9. So what is the square root of 9? 3 times 3, which is going to be 3. So you have to think to yourself, what number times itself gives me 9? 3. That's my answer from the square root of 9. What about this one? There's 16. So what's the square root of 16? 4. See, it's easy to see it when it's visual like this and you have 4 blocks. It's so easy to see the square root. So the square root of 16 is 4. And this one is 5 and 5, so this is 25. So what's the square root of 25? 5. Now, when you see the square root, you're going to have this radical sign right here, this little radical. So what's the square root of 64? What number times itself gives me 64? No, 6 times 6 is 36. 8. 8. Okay, and then what about for 100? 10. 10 times 10 is 100. Okay? And like I said, I want you to concentrate on the positive one, even though there is a negative, positive and a negative. Let's see if you guys know these. What about the square root of 121? 11. Okay. And what about 441? 21. 21 times 21 gives me 441. Okay? Now you guys need to make a list up to 25. I want you to give me the squares. I've done 1 through 5 here for you, but I want you to do all the way through 25, because if you practice this, then this will be natural for you, and you won't have to reach for your calculator. Now, when we have to do square roots that are decimal square roots, I will allow you to use a calculator for those. If they're not a perfect root, I will let you use a calculator. But right now, these are going to just be perfect roots, so you don't have to worry on today's assignment, okay? So what did we say the square root of 4 was? Square root of 9? Square root of 16? These are perfect roots. That's why I'm doing them. Square root of 25? 5. Well, if we can do that for squares, we can also do it for cubes. And I would like you guys to do a cube root chart, just like we're doing the square root chart, but just do it up to 10, okay? Start one with the cube roots, but do it up to 10. So we know that on the cube roots, it's going to be 1 times 1 times 1 equals 1 to the third. Now remember to put a little 3 here to indicate that it's a cube root of 1 is 1. Then 2 times 2 times 2 is 2 to the third. What is that? What's 2 to the third? 8. So what you want to say is the cube root of 8 is going to be 2. What about 3? So the cube root is going to be 27, which gives me 3. So I want you guys to do this list all the way up to 10. And you know the last one, the 10, is going to be easy because it'll be 10 times 10 times 10, which is 1,000, right? So you fill in from 3 to 10. I've already started you, and you have those charts, and it really does help you to actually physically do those charts, because even if you're taking a test, you can do a chart during the time frame, and it's really a short exercise to do to figure out your roots. So visually, let me show you what the cubes would look like. So this is an example of a cube root with 2's in it. And we know that 2 times 2 times 2 is 8. So the cube root of 8 is 2. And here's a visual representation of it. It's just like maybe if you think of volume. Volume is a good relation for that visually, for those of you that are visual. And then let's do 3 times 3 times 3 is 27. So let's see what that looks like. Okay, so that's a bigger cube. So the square root of cube root of 27 is 3. And make sure you put the little 3 there for cube root. Then let's look at a chart here. I don't want you guys to cheat and get the answers, but here's an example. You can do these. This is one I did up to 30 for square roots. And then I'm going to want you to do one for cube roots, okay? So I told you guys to do up to 25. You don't have to do up to 30. So you're going to do 25 to the second power is equal to 625. And the square root of 625 is 25. Okay, that's as far as you have to go on your extra work for today. If you want to do up to 30, you can. That's not a penalty. But this is what your chart should kind of look like. I actually put out the multiplication so you can see what we're doing when we're multiplying it, since this is new to you. So this is just one that I put together. And then the cube root one, this one I did to 9. I want you guys to do to 10. We did the cube root of 1, the cube root of 8, the cube root of 27. So if I did 4 times 4 times 4 is 64. So you need to do that one and do it all the way down to 10. So here's an example of a chart. So you guys need to have your own chart. And I will be looking for that when I do our book check next Thursday. Now, on Thursdays is when I check you guys' progress, and I know a lot of you came in at different times. So today, we will not have anything due that I will check. But next week, I will check for these 2 weeks, okay? So you guys have up to 2 weeks to get everything caught up. And remember, we are working on week 1, but you also had things to do in week 0. Okay? So you're going to probably be wanting to get on the computer and get some work done on the computer today. We have a lot to do. So Lavelle was telling us about PEMDAS, that P stood for what? Parentheses. And E stood for? Well, it's more than exponents, we know. It's exponents and roots, because those two are evenly weighted in math. So E stands for exponents or roots. And guess what? Your square roots and your cube roots and your fourth roots and your fifth roots can be written as exponents. So that's why they are all grouped together. So first, when you're trying to solve an expression or an equation, and the only difference between them is an equal sign. In an expression, you want to go to anything that's in parentheses or has brackets first. Then you want to go to any exponents or any square roots or cube roots. Those are evenly weighted in math, and you do them from left, right. Everybody say that. Left, right, left, right. You do it in that order. So if you have a square root that comes before a square, you do the square root first, because from left to right it came first. So whichever comes first from left to right. Same thing with multiplication and division. MD stands for multiplication and division, but multiplication and division are evenly weighted in math. So whichever one comes first, you do first. If division comes before the multiplication, you do it first. And A and S stands for addition and subtraction. Same thing. They are inverse of one another, evenly weighted in math, and whichever comes first from left to right, you do. But if I have multiplication and then subtraction, of course I do the multiplication first, because it's got a hierarchy that's higher than subtraction. Now there's a little way to remember PEMDAS. Some people have trouble with PEMDAS, so I like to use this little phrase. Please excuse my dear Aunt Sally. Acronyms are nice little quick ways for you to remember rules and processes in math, and I like to use them a lot. So for the order of operations, I use, please excuse my dear Aunt Sally, left, right, so I even remember the direction. So you guys want to sing that with me? I know it's early in the morning. 1, 2, 3. Please excuse my dear Aunt Sally, left, right, right. Hello? I only got half of that. Come on, let's try it one more time. Please excuse my dear Aunt Sally, left, right, right. That's just a quick little quirky thing for you to remember how to do it, okay? Again, the P stands for parentheses. It can be brackets. It can be curlicues. Exponents is what the E stands for, but we know exponents also include roots. Multiplication and division, evenly weighted in math from left to right. Addition and subtraction, evenly weighted in math from left to right. You do them. Always, always, always go to your parentheses and evaluate what's in that parentheses first. Then go to any exponents or radicals, and the radicals we know are straight square roots or cube roots. Multiplication, division, addition, and subtraction. So let's do some examples. See if you guys got it. What's the answer here? Number 1. Everybody say 14? What do you do first? Parentheses. So 12 minus 3, which is 9, plus 5 is 14. And what I like to do is I like to do it one step at a time. What do I do? Put it in order so I can trace back what I did. Now, number 2, what do I do first? This means multiplication here. So I have to multiply. Then what do I do? Subtraction. What do I get? 2. Okay, and then what do I do? 9. Okay, what do I do first here? 9 plus 4 is 13. And then what's 39 divided by 13? And what do I do first here? 20 plus 1. I have to go to parentheses. Then what do I do? And what will that give me? 100. And then what do I do? Nope. Left, right. I do the multiplication first. 100 times 21 is 2100 divided by 7, which is 300. Then we have this example. What should I do first in this example on number 5? Please excuse my dear Aunt Sally. Left, right, left, right. The division. So I get a 4, and then I do the addition, which is 14, and then I do the subtraction, which is 8. What do I do first here? So how much is that? And what's 15 times 1,000? 15,000. Ooh, what do I do on this one?
Do the 1 plus 2 first. 3.
Parentheses first. So I have 36 divided by 3 to the second power. Then what do I do?
And you 3 to the second power, which is
What's 3 to the second power? It's 9, not 6. And then what's 36 divided by 9? 4? What should I do first on number 8? The exponent. So what would I get? That's 2 times 2 times 2 times 2. How much is that? 16. Okay, and then what do I do with that? Multiply by 5 and I get what? You guys are weak on your multiplication, aren't you? You guys are having trouble with your multiplication and division. Okay. Because when I ask you to multiply and divide, you guys are so like, okay, what is that? All right, I've got 2 problems that are set up like the GED or compass, and I'd like you guys to solve problem 1 and problem 2. Solve those. I think let me put this one up first. And you tell me what the right answer is on number 1, and then I'll put up number 2's.
number 4.
So you say it's 32? Does everybody say it's 32? No, try it. Try it right now before I do anything. I haven't given you the answer. That's what I'm asking you. Is that correct, number 4, that says 32? It is? Okay. All right. Now try number 2 and tell me which of those is correct. Okay, you think it's 64? Okay. Does everybody agree that it's 64? Or did you get a different answer? What do I do first?
Parentheses 4 plus 3.
So how much is 4 plus 3?
7.
And then what do I do?
2 times 7.
Which is what?
2 right outside the parentheses. 14.
It's 14. So 2 outside the parentheses means multiply. You guys do need to know when you recognize multiplication, okay? Multiplication can be 2 times 3. It could be 2 times 1 plus 2. It could be 2 with a time sign 3. It can even be the computer sign. And then a lot of people don't recognize it when it's a parentheses. You could have it like that. You could have it like this. Or you can even have it like this. So both of them could have parentheses. Only one could have a parentheses with the number on the outside on either side of it. So all of those mean multiplication. And you have to be able to recognize that multiplication, those different symbols. So is 64 correct, or should I choose a different answer? Hello? Is it correct? Okay. When I say hello, that means, okay, please answer me or rethink it, okay? Try these two. Zero, okay? So that would be number 4. And how did you get 0?
Fifteen divided by 3 is 5.
15 divided by 3 is 5. And then 45 divided by 5 is 9.
9
9 minus 9 is 0. Okay, now this one's going to take a little while, so you guys do this one. And tell me what you get. Take a minute. And every time I teach this class, everybody gets this one. They have trouble with this one. So take your time. Please excuse my dear Aunt Sally, left, right, left, right. Try that one, number 2. Number 3, so you got 102. Did everybody get 102? Everybody get a chance to try it? Go ahead and try it and see what you get. So what are you doing first?
I did the first and 6 to the second power.
How much is that?
6.
So 6 times 6 is 36. And then what should I do next inside of the parentheses?
21 divided by 3.
Which is 7.
7. So then you do 36 plus 7.
Is,
I wrote it down.
what's 36 plus 7?
43.
43. Okay. Now, what do I do
And
next?
then I did the 5 times 2.
5 times 2 is 10
Okay.
on the end,
And then I went back to 135 minus 43,
which is,
which was 92.
okay,
And then plus 10 is 100.
so 135 minus 43 gave me 92, and then I added 10, and I got 102. Okay? And if you didn't do that slowly and really think about what you were doing, you could come up with some of these other answers. So the correct answer is 102. Now, things that you need to remember about the order of operations is, please excuse my dear Aunt Sally, left, right, left, right. Parentheses, exponents, multiplication, division, addition, and subtraction. Now, I think I only gave you guys page 2 is some examples, but you've got 24 problems on page 3, 24 problems on page 4, so just 48 problems to go through. And what I'd like you to do is find a table mate or a classmate to work these out with so that you can bounce off the answers or bounce off the process, and try to get these 48 problems completed today. And what are you supposed to do after you've completed the packet? Well, after you finish this, what do I want you to do?
Oh, is it just you want us to do this, right?
I want you to finish the square and the cubes charts, because that needs to be attached to this, so that when I check it next week, I can give you full credit. But you need to check your answers before you go to the computers, okay? So take those 48 questions that you have answered, check the answers in the answer key. I have put the answer key in the binder. And once you're done with this, you're going to hole punch it and make sure that it's in your binder, because one of the requirements of this class is to have a binder to put your math papers in. I'm not requiring that you purchase a book. This is going to be your book. Then when you're done, there are 2 math requirements at the bottom. They're websites that you go to, and you're going to do those 2. Then you're going to do your pre-test and your post-test for this topic. Now be sure to ask me questions if you get stuck on any of these, especially if you're not really comfortable with your multiplying and dividing and you cannot use a calculator. This is something that you should be able to do without a calculator, this packet. Also, if there's any debates on the test, let me know and I can do them. And I can always give you credit when you need it, okay? Any questions, you guys?